So let's solve a little bit of a more complicated or complex problem. It's just a little bit wordier. It's really not much too different than the earlier problem and proportions that we had. But remember what we need to do to work with this. Okay, let me get my pen working here, Control Z. All right, so here in our problem, it's our 7th problem of the homework, exercise 731, as far as the text is concerned. And basically it's referring back to a Quality Progress February 2005 reports on improvements in customer satisfaction and loyalty made by Bank of America. Okay, so good. Here's an applied problem. And there was a customer satisfaction survey that went out, and they consider a 9 or 10 as being customer delight. Okay, and it said that we ended up with a proportion that 48 about 100 or 0.48 or 48% of respondents were delighted. Okay, find the probability that the sample proportion obtained from the sample of 350 Bank of America customers would be within 3 percentage points of the population proportion and within 6 percentage points of the population proportion. We're going to do this twice. And you can see it's a probability that our sample proportion falls between 0.45 and 5.1. And then we'll do it again with the proportion between 42 and 54. Okay, so let's get some of these numbers down here. We have n is equal to 350. Is it legit to perform this operation on there? So n times p is equal to 350 times approximately 50%, which that's going to be about 175, well greater, enough greater than 5 to not worry about it. And then n times 1 minus p, again, it's going to be 350 times approximately half, 0.5, so you're going to get about another 175. We're well in the safety zone of using that approach to this. Okay, so let's draw what we're talking about here. We have some proportion like this. Okay, and this is just going to go back to our classic study or understanding of using the normally distributed nature of our proportions here when we're doing sampling. And we want to know what lies between 0.45 and 0.45 and 0.48. Okay. So we know the proportion is going to be the proportion of the population, and we know that our standard deviation is going to be the square root of p times 1 minus p over n. Okay, so let's punch those numbers in here and get ourselves started. So we need to do the square root of, I will put the proportion here, star 1 minus the proportion over n, which I'll put on it's giving me a problem here. It's not letting me go ahead and do this. Square root of p times 1 minus p over n. That goes the square root, and we probably want to put a set of brackets, or rather parentheses, around this numerator calculation. Okay, and we get a number, assuming we did that correctly, it's 0.02675, something like that. Okay, and now we want to take a look at using our z-score is our points of interest. How far away is it from sample mean over standard deviation of those sample means? And remember, I'm just going to be repeating myself. We've been doing this in other problems. I'll draw a little diagram over here. Whenever we use a z-score is useful when we have normally distributed data. And here's our mean. And what it gives us is the typical one that we use gives us the area or the probability up to and including some point of interest. Okay, so that's our point of interest. And so what we're going to have to do in our calculations is we're going to have to calculate this once, and then we'll apply the fact that it mirrors to the other side of the mean here, which is B. And so what we really want is area C, so it's going to be 1 minus 2 star, whatever that probability is that we draw out of the Z table. Okay. So we use Excel to figure out this probability where we're 0.03 down on the x-axis and up 0.03 on the x-axis. All right. So our point of interest is going to be, Z is going to be equal to 0.45 minus our mean, our proportion is minus 0.48 over our standard deviation there. Let's see if we have enough parens, and that looks good. And we have to enter in our 1. And so we get this probability of 13%. So 13% of the area lies to the left of our lower number, the 0.45. Okay. So now what do we need to do? We can develop our spread here because we know the center point was 0.48. I'm going to paint these yellow because this is where our answer is going to be. We're developing a set of brackets here. And we know that our 0.51 is our upper bracket. Our lower is 0.45. Okay, and we're looking at the area C between these 2 points. Okay, so that's going to now be, we're going to multiply that by 2. It's equal to this times 2. Subtract that from 1. So 74% of the means of our proportion will lie between 0.45 and 0.51. Let's check this out, see if we're anywhere near it. 0.7387, we're close. Might be off by a rounding error somewhere in there. Okay, and let's just do that really quick because I think I'm not exact. Let's make sure that we get this correct. That equation looks good. Just looking for somewhere where we might be picking up a little bit of a rounding error on that. Pretty close. Okay, so this other set we're going to get is we want to know if it's 0.48, but between 0.42 is 0.06 down, and 0.54 would be 0.06 up on the curve. So we can perform the same equation as we did here. But we'll use the appropriate numbers. We're going to do, I'll use the same spot on the graph here, is norm.s.dist. Put our equal sign in there before we get too far ahead of ourselves. What is z? Z is going to be equal to 0.42 minus our proportion over the standard deviation. Let's make sure we have enough brackets in here to suit our needs. And we just need to put our cumulative function in there. Right. Okay, so by going out another 0.03 in each direction, you'll see when we're done with this, we can take these two numbers here and just copy them in here. They should work. Okay. All right. So we went from 73% when we did plus and minus 0.03. When we went to plus and minus 0.06, we went to 0.97. So when you tease the data around these problems, remember that 0.97 is getting up toward 3 sigma, right? Okay, so what we should see is here's our standard deviation, right? And what we're really saying is, what were the two numbers we looked at? We looked at 0.03. 0.03 is a little bit bigger than the standard deviation. It's like 1 and change. And 0.06 would be a little bit more than that, okay? So you have to relate to the types of things that we're doing here. We're taking some arbitrary points so far away from the mean plus and minus. And when we do that, why don't we just inspect what the standard deviation is that we calculated? Okay, so how close did we come here? So this time we came out right on. I'm not sure why there's a little bit of a rounding error in the first one, but okay, we're pretty close. So we introduced this concept in part B of the margin of error is what's left over after we look at our sampling performance regarding the anticipated population, okay? So this is exactly what you're going to see on the news if they do things well in polls, opinion polls, no matter what they might be, political or otherwise, all right? When they talk about what the margin of error is, we're approaching, and we have gotten into the really important part of the statistics course that we're in here, margin of error. Is it plus or minus 3 points or plus or minus 6 percentage points? If we let, or we allow, let's put it this way, if we allow our sample mean to drift plus or minus 3 points around the mean, we're only capturing 73%, 74% of the curve. That's 26% margin of error. When we look at plus or minus 6%, we came up with the fact that we're grabbing 98% of the curve. We only have like a 2% margin of error. We're leaving the times that we read the sample mean outside these brackets is only 2% of the time. So we're capturing 98 and our margin of error is 3. So if we take a look at what they're talking about, let's see what they come up to. So they're saying you want to be closer to plus or minus 6 percentage points around the mean to capture enough that you have this low margin of error.